Okay, let's look at acids, bases, and salts. First of all, we've probably heard of acids and bases and pH. And I want to make sure we understand exactly what an acid is compared to a base, and as well as a salt. Um, and understand a little more about the measure of acidity, which is called pH. This is going to be extremely important because we, when we do diagnostic testing, either blood tests, urinalysis, we often look at the pH of those solutions, those body fluids. And there's a number of conditions that might disrupt the pH of your bloodstream. And we call those acidosis or alkalosis. And that's a key indication that something might be wrong. Typically, the organs that are responsible for maintaining blood pH are the blood itself, but also your respiratory system and your kidneys. So if pH is disrupted, we often will look closely at lungs and kidneys. So first off, pH is a measure of the concentration of H+. H+, we know what H stands for, it's hydrogen. This is often referred to as a hydrogen ion. It's a hydrogen cation because it's positively charged. If you recall, I mentioned in a previous lecture that hydrogen has two subatomic particles. It has an electron and a proton. In order to form H+, that must mean that that hydrogen atom lost its electron. So another name for H+ is a proton. The reason why I emphasize this is sometimes you will find that in information you might be reading about maybe a certain drug, or when we're learning about the kidneys and how they regulate pH, or we're learning about stomach acid, you might see this referred to as a proton. If you only learned it as a hydrogen ion, you would not understand exactly that those are the same thing. For example, we have little channels called proton pumps. Well, those proton pumps pump protons, but also hydrogen ions. They're the same thing. Okay? So the more of these you have in a solution, the more protons or hydrogen cations, the more acidic you are. The less of these you have in a solution, the less acidic you are. Then if you are basic, you have hydroxyl ions. Hydroxyl ions are OH minus. Okay? So if you combine those two, if you were to look at the hydrogen ion and hydroxyl ion and put them together, you would make water. So water has an equal number of hydrogen ions and hydroxyl ions. Therefore, water is neutral. So you can think of water as being neutral. If you have hydrogen ions, you're acidic. If you have hydroxyl ions, you're basic. And this is a scale. You can see the scale here on the side. 7 being neutral, that's pure water. You go below 7, you become more and more acidic because you have more and more protons released. So by definition, an acid is a molecule that when placed in water dissociates or splits apart and releases hydrogen ions into the solution. So hydrochloric acid, HCl, is a very strong acid because it easily releases these protons into solution. And hydrochloric acid is what your stomach produces. Potassium hydroxide, KOH, is a base because when it gets put in water, it releases that OH minus. So it is basic. Potassium chloride is neither. It's not an acid, it's not a base. Not all molecules are an acid or a base. What this molecule is, by definition, is a salt. A salt is when the molecule dissociates into, a cation and an anion. We often refer to sodium chloride as salt, but potassium chloride is also a salt. So then we also have to introduce what a buffer is. A buffer is a molecule that stabilizes a certain pH. Now, it could be a buffer that stabilizes at 5. It could be a buffer that stabilizes at 8. It all depends on how that buffer works. An example is our blood has a buffer in it. It's called bicarbonate. Bicarbonate stabilizes our blood pH at roughly 7.4. So notice blood is just above neutral. So your blood is what we call slightly alkaline. Alkaline is another name for basic. In order to keep it slightly alkaline, your blood has a buffer called bicarbonate. Notice some of these other body fluids on the list. Urine is slightly acidic. Usually we say normal urine is about 6. So that's 1 pH unit below 7. So it's acidic. Now, a couple things to remember. Each unit on the pH scale is 10-fold. So it's 10 times. It's not 1 times. So if you go from pH 7 to pH 8, you are 10 times more basic, which is pretty significant. We call this a logarithmic scale for our pH. If you go from urine, which is pH 6, to coffee, which is pH just below 5, that's 10 times more acidic. Battery acid is very acidic. Stay away from battery acid. Stomach acid, somewhere between 1 and 2. So that's an extremely acidic body fluid. And then there's some of these other ones that you can see. Notice polluted or unpolluted water is roughly 5.8 or so. If you pollute water with things, it actually will become more and more acidic. And then these are some of these alkaline or basic materials, milk of magnesia, drain cleaner. There's sodium hydroxide. That's a very, very alkaline molecule. So just to review, we need to understand what an acid is, what a base is, what a salt is. We need to understand the scale, pH. Remember, the lower the number, the more acidic. We need to understand what a buffer is because we're going to be discussing bicarbonate when we get to the bloodstream. And we need to understand that the scale is, each unit is 10 times more acidic or more basic.